Okay, first part of Unit 8 review. The first page, you're simplifying the following expressions. Okay, here's the first problem. In a parentheses, you have 5x to the third power, and then the parentheses is over, and then you have a second power, then times x to the fifth power. So you want to be thinking simplifying these with 3 lines, okay, because it's all multiplication or division operations. So I put the times dot. So the bases I have, and I underline the problem, that means everything's going to be on top. You have a base 5, a base x, and then another base x, but that means I'll just add the exponents to the x. Okay, so 5's to the first, but it's in parentheses, so you distribute 1 times 2, that's 2. Then on x, 3 times 2 is 6. This other x, I just put a 5 down. Remember, in parentheses it has to distribute. Out parentheses it doesn't. 6 plus 5 is 11. Now if you look at these exponents, they're both positive, so they just remain in the same position. And then 5 to the second, I can simplify 5 to the second by taking 5 times 5, that would be 25. And then the x to the 11th cannot be simplified. Okay, so there's your simplified expression. 25 times x to the 11th power. Okay, next problem. We got 4 to the second power times 4 to the fifth power divided by 4 to the fourth power. So on top we have a base of 4. We have another base 4, so that means I add, then I have a base 4 on bottom. Okay, so on top we just go 2 plus 5. Okay, that's going to be 7. And then on bottom we just have 4 to the 4th. So we have 4 to the 7th divided by 4 to the 4th. Well, now that you have a 4 on top and bottom, you need to cross out the bottom 4, or whatever 4 has a smaller exponent, excuse me, and then subtract 4 from the top. You don't always cross it out of the bottom. It's wherever the smaller exponent's at. 7 minus 4 is 3. So it's 4 to the third after all that. So it would stay in the same position because it's positive. And then 4 times 4 times 4 gives me a product of 64. There's your answer. Okay, my next problem, I have a parentheses. Inside the parentheses I have a x to the third divided by y. And then outside the parentheses we have a fourth power. Times, and then I have 2 divided by x to the fifth. So remember, you can, in a multiplication problem, you can extend the whole division line. Okay, then make your 3 lines. So on top I have a base of x. These are exponents, remember, don't put those. Then a base of 2. On bottom I have a base of y and a base of x. So x on top, it would be 3, but it needs to be distributed. 3 times 4 is 12. Now 2 is to the first, and that's not in parentheses, so it will just remain to the first. Then a y is to the 1, and that is in the parentheses, so we have to distribute the 1 to the 4, and that's 4. Then the other x on bottom is to the fifth. Now, you have an x on top and x on bottom, so take out the x of the smaller exponent and subtract it from top. So 12 minus 5 is 7. Okay. None of the exponents are negative, 7, 1, and 4, so they all stay in the same position that they're in. Okay, don't move any of them. Then 2 to the first can be simplified, that would be 2. The variables cannot be. Variables means letters. Okay, and then the last problem of this section. You have a parentheses just on the top, and in the parentheses you have 8x to the 6th, y to the negative third, and then outside parentheses you have a negative second power. Now on bottom you have x to the negative third power, y to the second power. Okay, so on top, the bases, we have an 8 times an x times a y. Now on bottom, we just have an x times a y. Okay, so 8, 1 times negative 2 is negative 2. Okay. Now the x on top, 6 times negative 2 is negative 12. The y, negative 3 times negative 2 is positive 6. Now in the denominator, we don't distribute because the parentheses is not around the denominator. It's only around the top, the numerator. So negative 3, and then y to the second. Now I can cross some things out. X, now think about it. What's smaller, negative 12 or negative 3? Negative 12 is smaller, so we subtract that. And then not minus, it's got to be minus negative 12, okay? You can either punch negative 3 minus negative 12 into a calculator, or you can go plus plus, okay? You can't really see that very well, I realize that, but it was a negative 3, and I'm minusing negative 12, not just minus 12, negative 12. Negative 3 minus negative 12, or negative 3 plus 12 is 9, so it's x to the 9th power. Just put a 9 right there. 6 and 2 is pretty obvious, okay? You just minus 2, and that would be 4. Okay, now, here are my exponents, a negative 2, a 4, and a 9. Now, the ones that are positive stay in the same position. But the one that's a negative has to switch positions to the bottom, where it becomes a positive 2. It doesn't really matter the order it's written, but then 8 to the second would be 8 times 8, which is 64. Okay, so you have y to the 4th, and then 64 times x to the 9th. Okay, scientific notation. Simplify, write in proper scientific notation. Okay, one thing you're going to want to write here, okay, left is positive. It's like the opposite of a number line, okay? Left's positive, right is negative, so remember that, okay? It's the opposite of what you do on a graph or a number line. That's why people are confused by it, but if you write that, it's opposite of a number line. Think of it like that. Okay, so I've got 7 times 10 to the 5th times 2.3 times 10 to the 4th. You need to simplify and then write the answer in scientific notation. Now it's all multiplication, so multiplication's commutative, so you can just switch yours. So I'd take the 7 times the 2.3, then I would multiply the 10 to the 5th times the 10 to the 4th. Okay. So 7 times 2.3 is 16.1. Then on 10, 5 plus 4 is 9. Okay. Now, look in this direction. You have too many digits in front of the decimal. You can only have one digit. Okay, so looking this way, 1 is the first digit that's not a 0. So we need to move the decimal so it's between the 1 and the number after it. Okay, you move it one place. Now, if I moved it one place, I need to adjust the exponent by 1. Now, I moved it to the left, so I'll add 1. Okay, so 9 plus 1 is 10. So it's 1.61 times 10 to the 10th power. So again, if you have two digits in front, that's not going to work. Okay, you need to move it. Okay, next problem, we have 2.5 times 10 to the 5th divided by 5 times 10 to the negative 3rd. Now it's a division, so you split up the division. So it's 2.5 divided by 5, and then 10 to the 5th divided by 10 to the negative 3rd. So I divide 2.5 by 5, 0.5. Now, with scientific notation, you always cross out the 1 on the bottom and subtract that exponent from the top, so it's minus negative 3. You can either punch that in a calculator or plus 3, it's 8. So 10 to the 8th. Now, once again, the exponent has to be moved, okay? So look in this direction. The first number I have that's not a 0 is 5. So let's put a 0 so we have something after it. And we need to move it so it's between that number and what's after it. So 5.0. Now I moved it one place, but I moved it to the right. So instead of adding 1, we'll subtract 1. That's 10 to the 7th. So 5.0 times 10 to the power of 7. So again, these answers, you need to end up with one number in front of the decimal, and that one number cannot be a 0. It has to be one non-zero number in front of the decimal. Okay. See right here when I multiplied, I had two non-zero numbers. Well, I need to move it back then. Okay, left, which means I add to the exponent. Okay, here I had a digit, but it's a 0. You can't be a 0, so you need to move it that way. You moved it one place to the right, so you minus 1. Left positive, right negative. Minus, okay? Now graphing, okay? Y equals 1/5 times 2 to the x power. So it's an x power, put the operation of a upside down v, so it's an exponent. So that's an exponent function. Really, the only way to graph exponent functions is with a table. 2, 1, 0, -1, -2. Now just focus on the exponent part and then come back after you get your answers and multiply all of them by 1/5. Okay? So 2 to the x power. Well, we're going to put 2 in there. Now remember, I do 2 and -2 at the same time because it's very easy. So 2 to the second power means 2 times 2, that's 4. Now how do you get the -2? Well, you put a 1 under the 4 and flip it to 1 over 4. Okay? 1 and -1 are done the same way. They're like a pair. So 2 to the x power, now it's to the first power. 2 to the 1 power is just 2. Now put a 1 underneath and then flip it to 1/2. What's anything to the 0 power? Anything to 0 power is 1. Okay? X becomes 0. That's 1. Okay, awesome. Now you need to multiply them all by 1/5. Times 1/5 times 1/5 times 1/5 times 1/5 times 1/5. This is going to be a weird looking graph. Okay. So remember the 1 on the bottom you can cross out and it'd just be 4 times 1/5. So 4/5, okay? 2 over 1 times 1 over 5. Here, you can even go, if you don't want to cross out the 1, then don't do it. It's fine, okay? 2/5. 1 times 1/5 is just 1/5, okay? Then 1/2 times 1/5, 1/10. And then it would be 1/20th. Okay. Now, graphing fractions is confusing, so divide them into decimals. So 4 divided by 5, 0.8. 2 divided by 5 is 0.4. 1 divided by 5, 0.2. 1 divided by 10, 0.1. 1 divided by 20 is 0.05. Okay, so that's 0.8, 0.4, 0.2, 0.1, 0.05. So we can easily go by ones here on both of them, so I don't need to number it, okay? So I go forward 2 on x, okay? 0.8, it's like close to 1, but not quite there. 1, 0.4, it's a little bit below the halfway point, okay? 0, 0.2, it just is up even smaller, and then here you just get closer and closer to the line, okay? So we go infinitely higher that way, and here you just get closer to the axis without crossing it, okay? Okay, y equals 3 times 1/3 to the x power, okay? So again, put your x power, it's an exponent function, not a linear function. Slope y-intercept isn't going to get it. If it's times x, it'd be slope-intercept, but it's not. Okay. 2, 1, 0, -1, -2. So put 1/3 to the x power, and now put 2 in for the x. Remember, we're doing these separately. 1/3 of the second power, you just write 1/3 times 1/3. So you take 1 times 1, which is 1. 3 times 3 is 9. So 1 over 9. Well, then down here we're going to have 9 over 1. Okay. Okay, let's do the 1 and the negative 1. So 1/3 to the power of 1. Okay. That's just 1/3. If it's a power of 1, it's just the base. So down here it's 3 over 1. Anything to the 0 power is 1. Okay, you can just put 1 right there. You don't even need to write it out. Now all of these need to be multiplied by the factor of 3. Okay, so 1/9 times 3, 1/3 times 3, 1 times 3, 3 over 1 times 3, and 9 times 3. Okay, 1/9 times 3 is 1/3. Divide that into a decimal. 1 divided by 3, 0.33. So you multiply if you have a fraction. 1/3 times 3, I got 1. Okay. 1 times 3 is 3. Remember, this is just like 3 times 3 when you have a 1 on bottom. It's 9. 9 times 3 is 27. Okay. Okay, now we have to get all the way to 27, so we better go by 5s on it. We're always going to be going by 1s this way. But we better go by 5s here. It's positive 27, so I go 5, 10, 15, 20, 25, 30, and start graphing. Now, I would personally, if I were you, I would start with the highest part of the y first. I'd go with the negative 227, so I'd go back to 27. I'd just go wherever the higher numbers start. Then negative 1, 9, okay? 0, 3. Because then you know when you do these really small ones up here, all you're doing is just getting closer to the x-axis, okay? Okay, there you go. Okay, right in radical form, you have 81 in an x in parentheses, and you have this fraction power, 1/4. Okay. Again, you're simplifying it like that. So you got bases 81 and x. 81's to the first, but you got to take 1 times 1/4, that's 1/4. X to the first, 1 times 1/4 is 1/4. Okay, they're both positive exponents, so they maintain their position. And then I simplify the exponent here. So, remember how to simplify a fraction exponent. You draw out blanks. Blank times blank times blank times blank equals 81. Then you guess. 1 times 1 times 1 times 1. Nope. 2 times 2 times 2 times 2. Nope. 3 times 3 times 3 times 3. Boom. So that's 3 to the first, which is 3. Okay. Now, the variable you put inside of a radical. Okay. So you make a radical with a 4. Then inside you put x to the first. Okay. That's how you do radical. Or you can just put x. Okay, now write the 6th root of x to the 5th as a power with a rational exponent. Okay, you can do the same thing. Your base would be 5. Okay, and you would underline the 5 and put a 6. Okay, and then it's not negative, and I can't simplify it, so that is your answer. X to the 5 over 6 power. So you write x to the 5th down, then you just underline the 5, put a 6. And then really that's the end of the problem. Okay, now story problems. Okay, a customer deposits $600 in a savings account that pays 2.5% interest compounded quarterly. How much will the account be worth in 5 years? You see that word compounded, you're going to go to this formula right here. Okay, you don't make any boxes or tables, nothing. Okay. So A equals P, parentheses 1 plus R divided by N, just copy it down, and then the power of N times T. Okay, now we have to know what all this stuff, A stays the same, okay? So, we got to know what P equals, what R equals, what N equals, what T equals. Now, P is the initial balance, okay? Initial balance was $600, so P is going to be 600. Now, the rate, 2.5%, but you need to express it in decimal. Now, if you're like, oh, it's already in a decimal, yeah, it is, but you still need to move it, okay? Move it twice to the left. So 0.025 is the R. Now remember N, okay? N is a number of times in a year. Well, it depends if it says quarterly, annually, semi-annually, or monthly. This one said quarterly, so N is 4. And then T is a number of years, which we have 5, okay? So now you're ready to fill out your equation. So you got P, 600. 1 plus your rate 0.025 divided by N, which is 4, and then N times T, so it's going to be 4 times 5. Well, we take 4 times 5, that's 20. And then what I'm going to do today is I'm just going to punch that all in on a calculator like this. I'm going to go 600 times parentheses, key up above the 8, 1 plus 0.025 divided by 4, close the parentheses, and raise it. After the parentheses is closed, you hit your caret key, 20. That's your new balance, $679.62. Okay, and that was number 11. Okay, number 12. The population of a city is 45,000 people. It decreases by 2% each year. If the trend continues, what will the population be after 15 years? It didn't say quarterly, so you need to use your boxes. So we have people in years. So years is X, people is Y. So per people per year. Okay, well, it's not a people amount per year. It's a decrease of 2% per year. So I put minus 2%. And it happens every year, not every 2 years or any of that nonsense, okay? With a percentage, you need to take 100%, subtract 2% to get 98%. Then you need to move the decimal twice. So 0.98. That's your decay factor, okay? Now, when you make your table, XY, years is X, people is Y. 0, 1, 2. You can go 1, 2 because it's clearly states it's each year. Okay. So you start with 45,000 people. Now you don't add, you start multiplying by 0.98. Okay. So that's what happens with a percent. You got this many people. Then you multiply by the percentage. So 45,000 times 0.98, 44,100 times 0.98 again, 43,218. Now I want to know 15 years from now how many people are there going to be. Well, we don't make a line because when I'm multiplying, it's not a linear function, it's an exponent function. So then it's A times B to the X power equals Y, okay? So A is 45,000, and then B is a 0.98 to the X power, okay? Now we know X is 15, okay? So 45,000 times 0.98 to the power of 15 equals Y. Okay, and you can punch that into your calculator. Okay, there you go. 33,002. Now you're talking people, so just put the whole number. 33,236. Finding the people, so people equals 33,236 people. People isn't continuous, so no decimal. Okay. And then number 13. The human body cell normally produces about 2.2 times 10 to the 6 red blood cells per second. How many red blood cells could be produced in 30 minutes? So, per second. So please write 2.2 times 10 to the 6th, and then times the number of seconds, because that's how many red blood cells you have overall. Okay. Well, you're like, 30 isn't seconds, it's minutes. Well, you go off this side, you take 30. How many seconds are in a minute? 60. So you times 30 by 60. That's 1,800. So that's your seconds. You just take your minutes times 60. 2.2 times 10 to the 6 times 1,800. Okay, now we do what we did on another page. You want to split the problem up. You take 2.2 times 1,800, and then just leave your 10 to the 6 alone. Okay. $3,960. Decimals here, and then 10 to the 6 is just 10 to the 6. You got way too many numbers in front of the decimal, son. Okay. This is my first digit that isn't a 0. Decimal's got to go there between the 3 and the 9, so move it. How many times did you move it? 3. Did you move it left or right? You moved it left, so then you add 3. Okay, so it's 3.96. If you put the 0, I would not put the 0 at the end, but if you do, I won't mark you off. Times 10, 6 plus 3 is 9. So there you have it.